So here we have a set of parametric equations where x and y are both defined in terms of t. So if you input all the possible t's that you can into these functions and then plot the corresponding x and y's for each t, this will plot a curve in the xy plane. What I want to do in this video is figure out the first derivative of y with respect to x and the second derivative of y with respect to x. And in both cases, it's going to be in terms of t. So let's get to it. So first, let's find the first derivative of y with respect to x. First derivative of y with respect to x. And we've seen this before in other videos, where this is going to be the derivative of y with respect to t over the derivative of x with respect to t. And so this is going to be equal to, well, what is the derivative of y with respect to t? dy dt is equal to, well, let's see, the derivative of e to the 3t with respect to 3t is just e to the 3t. And then the derivative of 3t with respect to t is going to be 3. So I could say times 3 like that, or I could put that 3 out front. And then the derivative of -1, well, a constant doesn't change no matter what you do to your t, so that's just going to be 0. So that's dy dt. So it's going to be equal to 3e to the 3t. All of that over, well, what's the derivative of x with respect to t? Derivative of x with respect to t is equal to, well, we're going to have the 3 out front. And so the derivative of e to the 2t with respect to 2t is going to be e to the 2t. And then we're going to take the derivative of 2t with respect to t, which is just 2. So this is going to be 6e to the 2t. 6e to the 2t. And let's see, we could simplify this a little bit. I'll now go to a neutral color. This is equal to, so this is going to be 1/2. That's 3 over 6. E to the 3t minus 2t. 3t minus 2t. And I'm just using exponent properties right over here. But if I have 3 t's and I take away 2 of those t's, I'm just going to have a t. So this is just going to simplify to a t right over here. So now that we know we've now figured out the first derivative of y with respect to x in terms of t. Now, how do we find the second derivative? How do we find the second derivative of y with respect to x now? And I'll give you a hint. We're going to use this same idea. If you want to find the rate of change of something with respect to x, you find the rate of change of that something with respect to t and divide it by the rate of change of x with respect to t. So what this is going to be, we want to find the derivative of the first derivative with respect to t. So let me write this down. So we want to take the derivative with respect to t in the numerator of the first derivative, which I will put in blue now, of dy dx, all of that over dx dt. Now I want you to, if it doesn't jump out at you why this is the same thing that we did before, I encourage you to pause the video and think about it. Think about what we did over here the first time. When we wanted to find the derivative of y with respect to x, we found the derivative of y with respect to t, and then divided that by the derivative of x with respect to t. Here we want to find the derivative. We want to find the second derivative of y with respect to x. Actually, let me just write it down out here a little bit clearer. What we really want to do is we want to find the derivative with respect, let me write it this way. When we wanted to find the derivative with respect to x of y, that was equal to derivative of y with respect to t over the derivative of x with respect to t. Now we want to find the derivative with respect to x of the first derivative with respect to x. And so everywhere where you saw a y here, replace that with the first derivative. So this is going to be equal to, in the numerator, the derivative with respect to t of dy dx. Notice this was the derivative with respect to t of y. In fact, let me write it that way just so you can see it. So if I clear this out, we're going to get, this is the derivative with respect to t of y. So hopefully you see, before we had a y there, now we have a dy dx, dx dt. Now this might seem really daunting and complicated, except for the fact that these are actually fairly straight things to evaluate. Taking the derivative with respect to t of the first derivative, well, that's just taking the derivative with respect to t of this. And this is pretty easy. This is the derivative was just going to be 1/2, and the derivative with respect to t of e to the t is just e to the t. And so that's going to be over the derivative of x with respect to t, which we already saw is 6e to the 2t. 6e to the 2t. And so we can write this. We can write this as, let's see, 1/2 divided by 6 is 1/12, and then e to the t minus 2t, which is equal to, we could write this as 1/12 e to the negative t, or we could write this as 1/12 e to the t. And we're done.